Before we go into our next topic, we need to go back and review just a little bit, something we looked at earlier in the year. Here I have a sequence of values, and here's the formula for that. We know that this sequence is geometric. The question is, as n approaches infinity, in other words, as the value of n gets bigger and bigger and bigger and bigger and bigger, what is 1/2 to the n approaching? And we can see that when n equals 1, when n equals 2, n equals 3, n equals 4, n equals 5, as n continues to grow and grow and grow and grow, we see that 1/2 to the n power is going to approach 0, because we will get 1 over really, really, really big, which ends up being a really small number. 1 divided by 3 trillion. That's extremely small. And for all intents and purposes, it's virtually 0, even though it's not really 0. So as n grows, 1/2 to the n approaches value 0. Here's another one that might not be as obvious at first. As n grows, what's happening to a? So a is this right here. So let's plug in a few values and see what happens. When n equals 1. When n equals 1, we get -1 to the first, which is -1, divided by -1, so 1. -1, sorry, -1. So -1 to the first is -1, divided by 1 is -1. 3 plus -1 is 2. When n equals 2, n equals 2. We get -1 squared, which is 1, divided by 2, which is 1/2. 3 plus 1/2. We'll use the decimal here so we can see where things are going a little quicker. N equals 3. -1 cubed is -1. Divided by 3 is -1/3. 3 plus -1/3, -2.6 repeating. N equals 4. We get 1, because it's -1 to the 4th, even power, positive value, 1 over 4, so 3 plus 4th, 3.25. And look at what our values of a are doing. Here, it's less than 3, it's bigger than 3. That should not be a negative number. Less than 3, greater than 3, although these two are closer to 3 than these two. Let's keep going a little more. N equals 5. We get -1/5, which is -0.2. N equals 6. We get positive 1/6, which is 0.16 repeating. Just the 6 repeats. As n is growing, what's happening to our value of a? You notice that the value of a is getting closer and closer and closer to 3. Let's look at the odd values. 2, 2.6, 2.8. Look at the even values of n. 3.5, 3.25, 3.16. They're both zeroing in on 3. And that kind of makes sense. Let's pretend n is really big. N equals 100,000. Negative 1 to the 100,000 power. Well, that's positive 1. 1 over 100,000 is 1/100,000th. It's very, very small, which is 3 point lots of zeros and a 1. Very, very close to 3. The bigger n gets, the smaller this gets. The bigger this gets, the smaller n gets. So we're adding less and less and less and less. Or in the case of an odd value of n, we're subtracting less and less and less and less. So as n grows, it will approach 3 from both sides. Here's another one. As n gets really, really, really big, what's happening to b? Well, n equals 1, b is 2. N equals 2, b is 4. N equals 3, b is 8. N equals 1,000. B is a big number. This one's growing forever, so it's approaching infinity. This one's not really approaching any number. It's just growing unchecked. And it makes sense. This is an exponential. You should have recognized this right away as an exponential. Exponentials grow forever, very quickly. Let's do the same thing, but now with a sum. Again, you might recognize this as a geometric series. So let's look and see where this is going. If we just look at the first term by itself, we get 1. If I just look at the first 2 terms, just add these together and nothing else. Just ignore all this stuff. I get 1.5. If I take 1 plus a half plus a quarter and stop, just stop there. 1 plus a half plus a quarter. Well, that's 175. And if I add 1/8, stop there. $1.875. And now if I add a 16th and stop. $1.9375. And we can see that we're getting close to something. We're not growing as much in each new step. And it appears, as we continue, it appears that the sum approaches 2. And if you remember how we do geometric series, the sum as we go to infinity is t sub 1 over 1 minus r. 1 over 1 minus r is a half. That does equal 2. Here's another one. Again, I'll just start one term at a time and just add one term each time. So if we just look at the first term by itself, it's 1. If I subtract a third from 1, 2/3. If I take 1 minus a third, and then I add 1/9, and then stop there, I am at 7/9. if I take 1 minus a third plus a ninth minus 1/27th, I get I will get, not that, there we go, 20/27ths. Calculator issue for a second there. And so on. So as we continue, our sum will approach something. And as we saw again with our geometric series approach, first term, 1 minus r. R is negative 1/3. That is not right. We get 1 over 4/3, which is 3/4. And if I just look at this value right here, 20/27ths, it's approximately 0.74. And because these terms are getting smaller a lot faster, we approached this value quicker. So in all these examples, we are doing what's called a limit. As x approaches something, our sum was approaching something. We're going to apply that concept to functions. As x approaches some value, what is f of x approaching? This is a very important concept in mathematics. We don't care what the function value is. What we care about is where is it going. Think of a limit as the journey, not necessarily the destination. Where are we going towards? We don't necessarily have to get there. This is notation. This is some notation. So we see this lim. Underneath it, we see x, arrow c, we have f of x, and we have this equals L. And here's what that means. The limit of f of x as x approaches c is equal to L. We call the limit value L, capital L. X approaches c. X is getting really, really close to some value. C is a constant, so x is getting really, really close to something. What is f of x? In other words, what is y getting close to? We're going to start by looking at these graphically. So here's a graph. It's our favorite quadratic. F of x equals x squared. And question I have, limit of x squared. Could also put the limit of f of x. The limit of x squared as x approaches 3 is equal to what? So let me look at my graph. Here's x equals 3. I don't just look at 3 and say, oh, there's the value. I look to the right of it and I look to the left of it. So, to the right of 3. And now I'm going to follow the graph towards x equals 3. What are my y values doing? Well, they're getting lower. As I go to the as I go to the left, my y values are falling, they're falling, they're falling. As I get really close to 3, my y values get really close to 9. Now I come to the left side. I'll just start here. Follow the graph. Watch my x values rise. As my x values rise, so do my y values. And as I approach 3 from the left-hand side, what's happening to my value of y? It's getting really, really close to 9. As I get closer to 3, 2.7, 2.8, 2.9, y is getting 7 point something, 8 point something, 8.8, 8.9. As I get closer to 3, y is getting closer to 9. The limit is 9. And if you're wondering to yourself, well, this is a calculus students do this. This is supposed to be hard. Not really. We're just looking to see what are we approaching. If you're looking for complicated and difficult, don't worry. That'll come someday. For now, we're just going to look at the graphs. What are we getting really, really close to? Now, I could have done that for any point. At x equals 2. What am I getting close to? Again, I don't care what I actually am. What am I getting close to according to the graph? As I go from 1 to 2, x equals 1 is 1, x equals 1.1. 1.1 squared is 121. 1.5 squared is 2.25, and so on. As I approach 2, these values approach 4. As I approach 2 from this way, the y values are falling, and they're approaching 4 as well. Now for a little more complicated example. Limit of f of x as x approaches 1. Here's f of x, a piecewise function. Lots of pieces here. We don't care necessarily what the equations of those pieces are. We don't care. If we have the graph, we're good. So let's take a look at what we have. X approaches 1. So I'll start here, and I'll just follow the graph. My y values are rising, rising, rising. Now they start to level off. As I get close to x equals 1, what's y getting close to? Looks like 3. From this side, x is getting smaller. I'm getting closer to 1. What's y getting close to? Again, it's 3. Limit is 3. Next is to find the limit of f of x as x approaches 4. So here's 4. As I approach from the left side, watch the y values. As I get close and close and closer to 4, looks like they're getting close to 0. From this side, follow the path towards 4. As x is getting closer to 4, y is falling, and it's getting closer to 0. So our limit is 0. Next one. Find the limit of f of x as x approaches negative 1. Here's x equals negative 1. Follow the path. As x approaches from this side, we'll estimate that to be halfway between 1/2 and 1. So about 3/4. As I approach from this way, get really, really close to negative 1. Looks like we're approaching the same y value. So we'll say about 3/4. Sometimes we have to estimate. 3/4 is a pretty good estimate there. That's finding limits. from a graph. We just follow the path, go towards the x value that we want, and what is the y value? What is f of x approaching? What is the y value approaching? A couple more. Same graph. Same graph. Limit of f of x as x approaches -2. Now, the first problem you might see is, wait a minute, there's a hole there. -2 has a hole. Function is undefined. The beauty about limits is, again, we don't care. Limit is about the journey. Limit is about the journey. What are you approaching? Where are you going? We don't care if you actually get there, but what are you approaching? What are you approaching? So let's approach -2. As we get closer and closer and closer to x equals -2, y is getting closer and closer and closer to -1. Even though when x equals -2, y equals this number way down here. That's the function value. We don't care. What are we approaching? What is y actually approaching as it gets close to that? What is y approaching when we go from this way? We are approaching -1 again. We're not going to get there, but what are we approaching? So the limit is -1. What y value are we getting close to? We're not getting close to this. What is the function approaching? It's approaching a hole. Great. Where's the hole? If we ever can get to -2, which we can't because it's undefined, but if we can somehow reach it, we should be on -1, even though the function is defined elsewhere. What are we approaching? That's the question of a limit. Now, you've been noticing that I've been going from both sides. Why is that a big deal? Because now we're going to approach 3. From this side, approaching 3, y is getting closer and closer and closer to -2. But hold on, over here, if I go from the left side, follow the path, I'm getting closer to 3, y is getting closer to 2. So we're approaching 2 things. How do you approach 2 things that are different locations at the same time? How do you go to Red Robin and Culver's and get your oil changed all at the same time? Yeah, you can't. It's like walking to 2 classes simultaneously. You can't be in 2 places at once. You can't approach 2 different places at once. Can't be done. So what do? We have a limit of a function when x is going to 3. They don't agree with each other. So what do we do then? Don't worry, we will continue this in our next video.